For this review problem, we're going to do matching. Six different parametric equations are given, and the question is to basically match the curve with the equation. I should emphasize before we do anything else, for a problem like this, if this were to appear on the exam, all I would be asking you to do is basically plot this on your calculator and then be able to match the graph. We're going to talk about ways of being able to identify the salient properties of the parametric curve without plugging into a calculator. But that, for the purposes of an exam, that would be a perfectly acceptable solution. Just plot this on the calculator and see which graph comes out and match it with the options that are given. All right, but for this one, let's take a look at the options. Okay, so for number one, the answer is F. Now, why is this graph here the same as the graph of x is equal to t squared plus 1 and y is equal to t to the fourth? All right, a couple things that I observe is that t squared plus 1 must always be greater than or equal to 1. So that's something, t squared is always positive, or at least non-negative. And so t squared plus 1 must always be greater than or equal to 1. Also, t to the fourth also must never be negative. And I noticed that graph F is the only option of the ones given that satisfies both properties. The x-coordinate is always greater than 1, and the y-coordinate is always greater than 0. So I can identify it that way. Another thing I can do is solve for it. So if I see x is equal to t squared minus 1, I observe that x is equal to, let me say again, t squared will be equal to x minus 1. And therefore, y is equal to t to the fourth, which is t squared squared, which is x minus 1 squared. And so that's the graph of a parabola. Now, as it turns out, it's only half the graph of a parabola because x must be greater than or equal to 1, the way this is set up. All right, so if I were to actually see the plot of this, as t comes in, where t would come in negative, at t equals 0, come back here, then it would retrace the graph going back up. Okay, but probably the easiest thing to see is these two observations, that this is the only graph of the six options where all the x-coordinates are greater than or equal to 1, all the y-coordinates are greater than or equal to 0. All right, number two. For number two, the option is C. Okay, so let me write that here. So C is x is equal to t plus 1, and y is equal to t to the third. Okay, now why is that happening? If I again solve, I would see that x is equal to t, if I do the top equation, I see t is equal to x minus 1, and therefore plugging into the second equation, that gives me y is equal to x minus 1 quantity cubed. And so this looks like the graph of x cubed, except I have a horizontal shift of 1 going to the right. So that's how I can identify this graph as the graph of x is equal to t plus 1 and y is equal to t to the third. Okay, now for number three, the answer is going to be A. Let me put that on screen. So A here is the answer for x is equal to t to the fourth minus 1, y equals sine t. Now, how do I know that that works? Okay, well, the first thing I observe is that y is equal to sine t, and so that means that y must always be between -1 and 1. And so here, the y-coordinates must always be between -1 and 1. Also, the x-coordinates all must be greater than or equal to -4, and that's indeed what happens. Here's -4, and all the other x-coordinates must be to the right of that. Now, you noticed if you look down here that graph E also has those same properties. The y-coordinates go between -1 and 1, and the x-coordinates are to the right of -4. So how do I know that this one is A and not the other one? One way to be able to identify that is by looking at the x-intercepts. So let's look at the x-intercepts. The x-intercepts happen when sine of t is equal to 0, and that means that t must be a multiple of pi. Okay, and so the x-intercepts happen. That means x must be n times pi squared minus 4. Okay, so my options would be -4, 0 squared minus 4. I have 1 pi squared minus 4. I can have 2 pi squared minus 4, and so on. And that's kind of what I see here. So negative 4 I see here. Pi squared is roughly 10. 10 minus 4 is 6. And I see I have my next x-intercept at 6. 2 times pi, or sorry, that should have been 4 times pi squared. I apologize. 4 times pi squared minus 4. Pi squared is roughly 10. 4 times 10 is 40 minus 4. So this is something in the neighborhood of 36 without plugging into a calculator. And I see that the next intercept is at 36. And so given the options of A and E, this one is the better fit. Now coming down to E, number 4 is going to be the graph of this one. So let me switch colors again. So this one is E. That x is equal to t squared minus 4 and y is equal to sine of 3t. Now let's do the same analysis that I did before with the x-intercepts. The x-intercepts happen when y is equal to 0, so sine of 3t equals 0. And so 3t must be a multiple of pi, and so t must be a multiple of pi divided by 3. And therefore, the x-coordinate would be a multiple of pi divided by 3 squared minus 4. Okay, so let's see. If n is equal to 0, we would get pi squared. If n is equal to 0, I get 0 minus 4, which is negative 4. If n is equal to 1, I would get pi squared over 9 minus 4. Now, pi squared over 9 is something like 1. Negative 4, I would get another intercept to the left of the y-axis. That happens here. The next one would occur at 4 pi squared over 9 minus 4. So pi squared over 9 is a little bit greater than 1. So if I plug in this would be a little bit greater than 0. And I see that I have another x-intercept here that is close to the origin. The next one occurs when n is equal to 3. I get pi squared minus 4, which is roughly equal to 6. And that'll be this intercept here, and so on. So I've got more intercepts, so to speak. At least they come closer together in this graph than they did in the graph of A. And so that's how I can tell that this is the graph of t squared minus 4 sine 3t as opposed to sine 1t. And again, I emphasize that for the purposes of an exam, it would be perfectly acceptable to just simply plot this using a parametric plot to determine which one is which. All right, number 5. Number 5 is the graph of B. And the easy way, so x is equal to cosine 5t, y is equal to sine 3t. And the thing that's unique about this graph compared to all the others is that I have cosine of something, sine of something. And so I'm guaranteed that both x and y are somewhere between negative 1 and 1. And I indeed see that here. The x-coordinates go from negative 1 to 1. The y-coordinates go from negative 1 to 1. And so this is going to be the graph of this curve. Now, this is a very interesting curve. And you can actually get other types of curves like this by just playing with the numbers 5 and 3 and replace the numbers 5 and 3 with something else. Okay, lastly, so by process of elimination, 6 will be D. So this is equal to x is equal to 5 cosine t, and y is equal to 3 sine t. And the way I can tell this without plotting is that I see that x over 5 squared plus y over 3 squared, that's equal to cosine squared of t plus sine squared of t, which is 1. And so I see I have x squared over 25 plus y squared over 9 equals 1. And that is the graph of an ellipse, where the semi-major axis here on the horizontal has length 5, and the semi-minor axis on the y-axis has length 3, square root of 9. So that's how I can tell that this one is an ellipse. Again, for exam purposes, it'd be perfectly okay to punch these into your calculator and see what comes out and match those with the options. I just wanted to do this kind of descriptive analysis, comparing these equations to see how these equations are reflected in the graphs A through F.